Hello, high school and college math statisticians. We are looking at using normal distributions, and in this particular video, we're going to talk about using z-scores to figure out the percent of your data or the probability of finding data at certain parts, at certain values, greater than a certain value, less than a certain value, basically your area under the curve. But key thing here is we're looking at using z-scores. In my last video, we were not using z-scores. In my last video, we had scenarios like this. You have some data. You are told that it's normally distributed. That means it fits one of these. You're told that the mean is, let's say, 42. And that the standard deviation is, say, 10. Well, that means that this is 10 larger and 10 larger and so on. And in this direction, 10 smaller, 10 smaller, 10 smaller. Now, last video, before you got to this, you were talking about, well, what's the probability that the data falls between 42 and 62 or between 32 and 72, or how much of the data, what percent is less than 42 or less than 32 or greater than 62, etc. You were asked about numbers that you see here. Now we're getting into, you're asked things like, what percent of the data is greater than 47? Or let's say less than 47. It doesn't matter which one we say. So 47 is right here. Well, you can see that this is not the same size as this, even if I had done a better job of getting right in the middle. This part, this little rectangle, is shorter than this one over here, and it's not really a rectangle, but the shape, shorter than this one. The area under the curve here is not the same as the area under the curve here. So it's not like I could just split the difference and say, oh, well, if the whole thing here is 34%, then this is going to be 17% on this side of it. I can't do that because these two portions are not equal. So I have a problem. Okay, now here's where we need the z-score. And let's talk about what the z-score is. Remember that this is my mean, and we call it mu, and that this is 1 standard deviation bigger than the mean, and this is 2 standard deviations bigger than the mean, and this is 3 standard deviations bigger than the mean. So for instance, here I told you that the standard deviation was 10, so this is 42 plus 1 times 10, 42 plus 2 times 10, 42 plus 3 times 10. And so on. And this is 1 standard deviation below the mean, 2 standard deviations below the mean, 3 standard deviations below the mean. All right, so we need to think about how many standard deviations this is away from the mean. I know it's going to be a positive number of standard deviations. It's going to have a positive. Sigma is going to be positive. Remember, this is sigma. This stands for how many standard deviations. So sigma is going to be positive because it's on the right. All the way over here, these are all positive sigma values because they are above the mean. They were positive amounts above the mean. Amounts below the mean would be negative. Okay, so I do know it's going to be positive, and I know it's going to be between no sigma. This is like 0 sigma. This is no standard deviations away from the mean because it is the mean, and 1 standard deviation. As a matter of fact, 10 divided by 2 makes 5, and this is 5 above here and 5 below here. So this is exactly 1/2 of a standard deviation above the mean. So this is like sigma equals 0.5 instead of 1 or 2 or 3. Okay? So that's basically what a z-score is just figuring out how many standard deviations am I above the mean or below the mean when I'm not right on one of these points. So in other words, it won't be a whole number. If I'm 1 standard deviation above the mean, well, that's where I am. I don't need a z-score if I'm there. If I'm dealing with 52 or 62 or 72 or any of these numbers, I don't need a z-score. I only need a z-score when I'm a fraction of a standard deviation above the mean, like maybe 1/2 a standard deviation above the mean, or maybe 1.7, almost 2, excuse me, standard deviations above the mean, or maybe 2.5 standard deviations below the mean. So that's what we're figuring out, is how many standard deviations are we above or below the mean. Below is negative, above is positive. And so what we do is we take our value, and this is basically what we just sort of did instinctively. We said 47 minus 42, that's 5. Okay? Excuse me. And the size of my standard deviation here, the size of that whole section, is 10. So 5 out of 10 tells me I am 1/2 or 0.5 standard deviations above the mean. Turns out this is the formula right here. 47 was where we are. We call the place that we are our x value. 42 was the value of the mean. And if we're talking about a population mean, we're going to use mu. Okay, and the 10 came from how wide each of these sections is, which means how big each standard deviation is. So that's my sigma. And what you have right there is the formula for z-score. And I have it written out separately here. I'm having trouble putting my fingers on it. And here it is. So here's the formula for finding the z-score, which we basically just sort of figured out for that particular example. Okay, so the z-score for 47 would be 0.5. So you're basically taking whatever value you're asked about. In this case, I was asked what percentage of the data was above or below or whatever, 47. 47 becomes my x, and I figure out what is the z-score for that x. So the z-score for 47 was 0.5. Now, here's how that helps. We have a thing called a Zscore table. The Zscore table looks kind of scary. I'm telling you right now, it looks bizarre, or it looks a little bit much. This is a Zscore table, okay? The Zscore table is basically just a table of values for various z-scores. It tells you what is the percentage for that z-score. Well, what do you mean, what is the percentage? Well, we have to have a specific value here we're talking about. And what a z-score does is a z-score specifically tells you what percentage of the data as a decimal is to the left of that number. Okay, so let's say that this was my x. The z-score table, I would find my z-score first using the formula, and then I would go to the table, and whatever the table tells me for that z-score would be how much of the data is to the left of it. And it's really as a percentage written as a decimal. So in other words, if it's 50%, you would see 0.5. If it's 67%, you would see 0.67. Now, why does the Z-score table tell you to the left only and not to the right or anything else like that? Well, it's got to pick one. Basically, it was just somebody who, at the very beginning of coming up with these values, said, you know, we've got to pick a standard, and it's going to be, let's just let the table give the value to the left. Now, that makes it easy when we have what is less than, but if we're asked what is greater than or what is between two values, that means we have to do a little bit of fancy footwork. Okay, so let's go back to our example here and say, okay, we found our z-score was 0.5 and see how that would work here. Now, it was to the right of the mean, so it was positive 0.5. Positive values are right here on your z-score table. Negative values are up here. Okay, and it may seem strange to see -0 and +0 because we don't think of 0 as having a sign. Well, that's because we're not just going to stop with the 0 part. We're going to talk about 0.2. Come over here to 0.2. Or -0.3 or -0.7. So the negative is really for the rest of the part after 0. You could think of it that way. But if we're looking for positive 0.5, we're going to start at the positive 0 and go over here to 0.5. And this tells me that 69.15% of my data is going to be to the left of 47. Again, the Z-score tells you, the Z-score table tells you the percent to the left. Okay? So let's work with that a little bit. If we want to know the areas, and this is Z-score, this is some example problems. If we want to know the areas under a normal curve for which the boundaries are not 1, 2, or 3 standard deviations away from the mean, remember that's 1, 2, and 3 standard deviations, we have to use the Z-score formula and the Z-score table. Now, remember the answer is for less than. In other words, that's what I was just telling you. It's always to the left from there. That's always telling you what percentage of your data is to the left of that value. Okay? So we have to subtract from 1 if greater than. What does that mean? Well, let's suppose that this was, I don't know, let's say I have a mean of 50, a standard deviation of 6, and I'm asked about what percentage of the data is less than, let's go with 60. Well, 60 would not be, remember, on that perfect lines at 1 standard deviation, 2 standard deviation, 3 standard deviation, because they would be, let's see, here's 50, 6 would be 56, that'd be 62. So it would be somewhere in here. Okay? So we have to figure out what is the Z-score for 60. So 60 minus 50, find out how far we are above or below the mean, and then divide that by the size of each standard deviation to basically find out how many standard deviations we are from the mean. And this tells me 10 over 6, which is 1.6 repeating. I'll do that. Okay, so basically I'm 1.666 repeating forever deviations above the mean. So I go to positive 1, because I said 1.6 repeating, not negative 1. Positive 1, and I go over to 0.6. Really, I might want to round up to 0.7, because 0.666666666 is closer to 0.7 than it is to 0.6. And I say, okay, that means 95% of my data, 95.54% of my data is to the left of that value. Well, then how much is to the right of that value? We have to subtract. This was not in percent, it was in a decimal. So I found, sorry, this one right here. If I subtract that from 1, that's the same as subtracting my 95% from 100%. So 1 minus 0.9554, let me grab my calculator. Gives me 0.0446, or 4.46% of the data is over here to the right of it. So that's what's meant when it says we must subtract from 1 if we're doing greater than. All right, so let's go down here and try this problem. A light bulb company advertises that their 75-watt light bulb lasts an average of 500 hours with a standard deviation of 30 hours. Okay, so my pen is not doing too well, so let's see what happens when I try to trade. So average of 500, standard deviation of 30. I always do this first, because if the value I'm given is right on one of these numbers, that makes it so much easier, because I can use those standard percents that we've used before. Okay, find the probability of each scenario using the formula and table above. Sketch a picture to help you reference. What percentage of the light bulbs have an average life of less than 425 hours? So let's look at where 425 falls here. It's in between there somewhere. We don't have to be too precise about it. That's where we are. Now they want less than, so they want shaded to the left from there. That's good, because that's what the table tells us. The table tells us to the left. So I have to take this, because remember, the table doesn't say 425. We have to translate that number into a z-score. So my z-score for 425 is 425 minus the mean, all divided by the standard deviation size, which is 30. Okay, so let's do 425 minus 500. That gives me negative 75. And then divide it by 30. And I get negative 2.5. It definitely makes sense that it's negative because I'm to the left from the mean. So I get negative 2.5. And I go up here and I look first for negative 2. This is like almost like a stem and leaf plot. Here's your stem. So I go for negative 2. And then I go in that row, I go over to where I get to 0.5. And that is the percent of the data that is to the left of negative 2.5. Now remember, it's written as a decimal, so I have to take it back to a percentage, which means moving the decimal place 2 times. So this is so small, 0.0062 is still going to be less than 1%. And there's my answer. Let's see if I can fit them both on the screen there. Okay. Next one. What percentage of light bulbs, and I still have to use this same picture, so I'm going to see if I can erase. What percentage of light bulbs have an average life of more than 550 hours? Okay, so 550 hours, and notice how that would be asked. They're showing me the notation. It's basically what is the probability that X is greater than 550. I may have said 450. Either said it or thought it. So they want to know this area over here. Remember, the table tells us the area or the space to the left of. So if I want to know to the right of, I have to subtract from 1. So first thing I'm going to do here is I have to change 550 to a z-score. So the z-score for 550 is 550 minus the mean of 500, all over the standard deviation of 30. So that's 50 over 30. So that's 1.6 repeating. Let's call it 1.67. Okay, since we only go to the 10th place in the table, I am going to go ahead and round it to 1.7. So I go up here. It is positive. It's to the right. So it's going to be a positive. 1.7 is right here. And by the way, this table, it has a value shaded. That was just basically to show you how it works. This value shaded is for negative 0.6. There's nothing special about that value. It's just showing you how you go out the row and look down the columns to where they meet. Okay, so my z-score is positive 1.7, and that gives me a probability of 95.54%. Now remember, that 95.54% is what's to the left of there. So that's saying 95.54% is over here. So if I want to know what percent is over here, I can leave it as a decimal and subtract from 1. Or if I want to change it to a percent now, I could go ahead and subtract from 100. 94.54% is 4.46%. It's really the same number we just used on another problem. And that is my answer. That's how much, what percent of my data is to the right of that, which would always also be the same as what the probability is of choosing a point to the right of that. And I'm erasing just because I'm using the same picture again. Wish I had a better eraser. All right, next up, what percent of light bulbs have an average life of more than 450 hours? 450 is somewhere like here. More than, again, is to the right. And remember, the table always tells me to the left. So the table is going to tell me what percent is over here. And I have to subtract that decimal from 1 or that percent from 100%. First, I need to know the z-score. Always find the z-score first. Can't use the table without a z-score. So 450 minus 500, all divided by 30. That gives me negative 50 over 30. So it's negative 1.6 repeating, or negative 1.7. So I'm going to come up here and go to negative 1 and then across to 0.7, and I get 0.0446, which basically means 4.46% is over here. They asked about greater than that, so it's 4.46% subtracted from 100%, which we basically got in the last problem. We got 95.54%. We keep encountering the same numbers, but it was on the other side of the graph this time. Now, the last one here gets a little bit more interesting because it's not asking what's to the left or what's to the right. It's asking what's between. Okay, so let's look at this one a little bit more specifically. It says, what percentage of light bulbs have an average life of more than 430? Remember, my mean was at 500, but less than 520. Okay, so more than 430, and I don't know that it's exactly there, but I don't really care either. It's fine. And less than 520. So let's say 520 is about right there. Okay, so I'm looking for the area between these two. So here's what I have to do. I only find on the table the area to the left. So I'm going to find the area to the left of 520. I'm going to get the z-score for 520. Let's do that. 520 minus 500 all over 30 gives me 20 over 30, which is 2/3, or 0.6 repeating, or let's go ahead and round up to 0.7, positive 0.7. So I go to the positive 0. Then I need to find the z-score for 430. So this is 430 minus 500 all over 30. That's negative 70 over 30. And that's going to be negative 2.33 repeating. So that's going to be about negative 2.3. So those are my z-scores. Now, I'm going to start with the one that is farthest to the right and say if I can go to the z-score table and find the answer for this one, that'll be everything to the left of here. That's cool. So let's go to the table and look at 0.7. I'm going to use this table. 0.7. Right here, that tells me that 75.8% of my data is to the left. So this whole thing is 75.8% from there down. Now what I'm going to do, because that's not what I want, I just want the part in between these two. That's what I was asked about here, is in between. What I'm going to do is I'm going to find the part from here down and subtract that out. If I have this whole section and then I take out this section, I'll be left with just this part in here. So looking at z-score of negative 2.3, that's right here. It tells me that to the left of that is 1.07%. 1.07% falls in between there. Okay? So if I know this whole section is 75.8% and this part here that I don't want is 1.07%, then what I'm going to do is I'm going to subtract 75.8% minus 1.07%. Now I've been changing these to percentages. If you want to, you can just leave it as a decimal in the table until you get to the final part of the answer, final answer. And that tells me that 74.73% of my data is between there. Okay, let's think of it in terms of just doing it as a decimal. If I just did it as a decimal, 0.07, this is the first z-score I find, and I get 0.758. So that's what this was right here, 0.758. And then when I went and got my z-score for negative 2.3, I got 0.0107. So that's this part right here. So I'm subtracting 0.758 minus 0.0107. I'll just go ahead and put that here. And I get 0.7473, which is, now I can change it to a percent, 74.73%. And that is my answer. So 74.73%. So if you are trying to do between two numbers, you're going to have to find the value for the right one, because that's from the right one all the way over to the left, and then find the part from the left one and subtract it out. It's kind of like if you have a scenario where you tell me, okay, I want to just have every part of the curve that's to the left of this line. And I say, okay, here you go. And you're like, oh no, wait, I only want what's between the two lines. That's the subtraction part. So the first z-score is giving me this whole thing. The subtraction, I'm subtracting out the other z-score so that I'm only left with the part in between, which was the part I wanted. So let's finish up with just a few more quick problems to make sure we understand this. So here's an example of a problem you might be given where you're told to find the probability that a randomly chosen value of your data falls between 3.8 and 4.9. And you're given that mu is 5.2. And that the standard deviation size is 1.3. Okay, so I'm going to go 1.3 up from there, 1.3 up from there, 1.3 down gets me to 5.9. No, I'm sorry, 4.9. 1.3 down from there gets me to 5. I don't know what's wrong with my numbers here. 3.6. So basically, I'm just reassuring myself that these aren't the same values, that these aren't numbers that I can just, and actually I can in one case, can't I? No, because I don't know what I did. I just completely messed it up, didn't I? This is 3.9. This is 2.6. Okay, so I have now reassured myself that these are not values that I can just use and just use the empirical rule and the 34% and the 13.5 and stuff. I do know that I need to find a z-score. So first I'm going to find my z-score for 4.9. And remember, the formula for that is I take my value, 4.9 in this case, and I subtract mu, and then I divide it by the size of the standard deviation. So 4.9 minus 5.2 divided by 1.3 gives me negative 0.23. Okay, so there's my z-score, negative 0.23. And then my z-score for 3.8, which is over here, is 3.8 minus 5.2 divided by 1.3 again. And that's negative 1.07. I'm going to round it to the tenths. That's negative 1.1. This was 3.8. Okay, so what I'm going to do is I'm going to find out on the table everything, or what the percentage is, what's the probability of any point being to the left of this z-score. Then I will find out the probability of being to the left of this z-score and subtract that part. So negative 0.23, that's about negative 0.2, which is right here. So 0.4207. That's the probability of a point being anywhere to the left of this. Now I'm going to look at my z-score for negative 1.1, which is right here, 0.1357. And I'm going to subtract that because that's the probability of being over here, and I don't want over here. I want between there. So minus 1.1357 And in my calculator, that'll give me my answer. Pressing the decimal like it's, and I didn't even write the right thing there, did I? Minus 0.1357. There we go. That's what it should say. There's a 5 in there. And my answer is 0.285. So that is my answer for the probability, 0.285. And I think this video is more than long enough. I think I'm actually going to go back and cut this last part off. But just in case I don't, thanks for watching. Hope it helped, and I'll see you in the next video.